Here we are looking at a bad PID controller. I think this example is very interesting because it shows us how the PID controller works alongside the system we are trying to control. So in this diagram, the highlighted parts represent the dynamics of the vehicle, in this case our car, and we can see that the PID controller sits right in front of the vehicle, but it has nothing to do with the dynamics, the system itself. And what it does is it generates a voltage, and that voltage represents the voltage received by the DC motor, which in turn generates a torque. And the torque is used to provide the vehicle the acceleration, and the acceleration increases or decreases the velocity. And we are measuring this velocity and use that to compare with our target velocity to generate an error signal. Let's say we are at the very beginning, the vehicle is at rest, and so its velocity is 0, and we are targeting a velocity of 65 kilometers per hour, so we have an error of 65 kilometers per hour, and that is our input to the PID controller. So we can see here the PID literally just sits between the target value and the system, and it has no idea how the system actually works. It's like someone sitting in the car trying to drive the car and has no idea how the car works. Okay, so it just sees its current velocity and it knows the target velocity, and the only control it has is the voltage. The voltage here represents the it's like the pedal, okay, the throttle pedal on the car. So you can decide how hard you want to press that pedal, how much speed you want to gain, but you don't know how the system actually works. So we are generating a simulation of 100 seconds. Here we can see 3 output diagrams. The diagram represents they are measuring the arrow, the changing in arrow, the changing in the speed. This is the changing speed, and the voltage the PID is generating. Okay, so one thing to note here is that the arrow here is actually in meters per second. However, speed is in kilometers per hour. So as we can see at the very beginning, the vehicle is at rest, and then the speed should be 0, and it is 0 here. But at the very beginning, the arrow is not 0 because they are using different metrics. Different measures, different units. Okay, so we can see that what we are looking at the very beginning, we are receiving a positive 18 difference, and the PID controller is trying to compensate this difference by generating a rather small voltage signal. And that small voltage signal, as we can see at time step 1 here, this small signal causes the vehicle to speed up dramatically, and that is already giving us much more than the target. Okay, but what does the PID do at this moment? The PID didn't immediately, oh, by the way, the arrow signal at this moment is already going to negative, but the PID controller at this moment didn't immediately change the sign of the voltage. It's still generating positive voltage because it sees that it doesn't want to change the signal too fast, so it's trying to gradually decrease the signal changing. Okay, so between the time step 1 and 2, we see that the vehicle is still speeding up because at this moment the PID controller is still generating a positive voltage, and that is a positive torque, and that causes the vehicle to speed up. And at time step 2, we are already running at 120 kilometers per hour. And finally, at time step 2, the PID controller sees the arrow is significant enough that it's generating a negative signal, and that negative signal causes us to gradually speed down, and the rest just follows. I think the interesting to note here is how during those initial moments the PID controller doesn't change the voltage, the output signal trying to control, it doesn't change the signal dramatically. It tries to kind of ease in, ease out. It tries to gradually make a change. However, let's imagine an actual person is driving this vehicle. So at time step 1, we are already seeing that we are too fast. If I'm driving this vehicle, what I will do, I will immediately speed down. I will, immediately cause the voltage to go to negative. But the PID controller doesn't do this. The PID controller tries to kind of like maintain but decrease that trend, like how it gradually changes the signal. I think this shows some insight how this controller mechanism works. And as noted before, the PID controller really is just a separate component all by itself. It doesn't know the internal mechanics of the system.